Evaluate reverse Polish notation. You are given an array of strings, tokens that represent an arithmetic expression in a reverse Polish notation. So these are the notations or the operators they have given us. The valid operators are plus, minus, multiplication and division. Each operand may be an integer or another expression. So whatever the string they have given, it might contain, I'm explaining the second point where we'll just go to the question letter, just understand what are the points are. Each operand may be an integer or another expression. So it might be an integer or any plus or any negative or minus or any other expression like a percentage or any other expression might be there. The division between two integers truncates towards zero. So if there is any division operator, then it will truncate towards zero. There will not be any division by zero. So this is one thing, like if this is not written, then you can ask that is there any way where there will be not any division by zero. The input results is a valid arithmetic expression in reverse Polish notation. The input results, whatever the result is, it will be a valid expression. Whatever we are going to get the result, the input represents a valid arithmetic expression. So whatever the input we are getting is a valid expression. It is not an invalid expression. It is everything is a valid. The answer and the intermediate calculation is in 32-bit integer. So just to let you know that answer will be in integer format. What we have to find is evaluate the expression and return the integer that represents the expression. They have given the tokens in, just I'll explain you. They have given us the token which are in the which consist of integers and valid expressions. That is, we have four valid expressions which they have told us over here, that is plus, minus, division and multiplication. And what if you are dividing, suppose you are dividing 1 divided by 3, then that division will truncate towards 0. It won't be like 0 point something something something. It's not going to be like that. It will truncate towards, complete towards 0, and there will be nothing which is divided by 0 operation. So, and we have to do all this operation. So what exactly we have to do is, so here, right, this example which they have given, 2, 1 plus 3 multiplication. So we have to see whenever this operator is given, we have to go back and add these two integers. So here we have plus, right? So we have to add 2 plus 1, which becomes 3. Again, go ahead. See, 3 is an integer. We don't have to do anything. Again, go ahead. Here there is a multiplication. Once we see any expression, any valid expression, valid meaning, when I say valid, it should be between these four valid expressions. Okay, whenever there are one of the four valid expression, then you have to go back and multiply, or whatever the expression is, you just have to take that expression and add or multiply according to that particular expression. So here there is a multiplication. So 3 into 3, see, this will get cut because you did an addition and you got this 3, right? Now this 3 is there which is pending, and there is a multiplication. So you are going to multiply those two integers with the previous two integers, and you get the answer as 9. So the answer is over here 9. Let me explain you again if it's not very clear. We have given 2, 1 plus 3 multiplication, right? So I'm going to start from this position. This is an integer, this is an integer, this is plus. When I get a plus, I'm going to add the previous numbers. So previous number is 2 and 1, which is 3, and I'm just going to remove this numbers. So remove this numbers, and I'm just going to keep this 3. Again, go ahead, this is a number. Again, go ahead, this is a multiplication. What I'm going to do, I'm going to multiply this 3 and this 3. That is 3 into 3, which is 9. And I'm going to just remove this particular integer, and I'm going to return the valid integer which is in 32-bit integer format, and the answer is 9. That is what is given. This is what they want us to do. Okay, now how to solve this? Because I am removing it, right? You see, you if you observe, I'm just removing it. So how, which data structure, you can ask to yourself which data structure I can use, so that you have to remove it from that particular data structure and then do this addition and subtraction expressions. One data structure which we can use for this is the stack. We can use a stack for this. So when this is an example, right? Plus 3 multiplication. Okay, what we can do is there is a stack. I'll just maintain over here. In the stack, I'm going to add 2. I'm going to add 1. And when I get plus, I'm going to pop this. I'm going to pop 1. I'm going to pop 2. And whatever popped items, I'm going to add and say 3. Am I clear? When I get a positive expression, I'm going to pop the previous 2 items and add those previous and write 3. So these are popped. Again, move ahead. I get 3. I'm going to put it in my stack. Once I get a valid expression multiplication, I'm going to pop 3 and 3 and multiply it. 3 threes are 9. So I get 9, and this is the answer which I'm going to return. In this, the stack is very useful because we can easily pop out and we can easily push in, right? Push and pop is there. So we are pushing the numbers, and whenever there's a valid expression like positive or negative, we are just popping those two numbers and adding it in our stack again. The result we are adding in the stack again. Now let's take this is the approach, and this approach has time complexity of O of n and space also O of n, because we are using the stack. Suppose I'm using um, suppose there's a minus, like let's take this 2 1. I did a plus, right? Now I'll do minus a 3, and let's take division also. So let's do this. This is a stack. I'm adding 2, I'm adding 1, and whenever there is a minus, again I'm going to pop it off. I'm going to pop it off, and then I'm going to subtract it. I'm going to subtract in the format of whatever is bigger. They have not written that you have to subtract from 1 minus 2, or you have to subtract from 2 minus 1. It's just a simple valid maths we have to do. So 2 minus 1 becomes 1. And when the 3 comes, right? When the 3 comes, we are again adding 3. We're going to pop this. We done our, so this is 1. Okay, I just don't want to get you confused. So 2 added, 1 added. When there is a minus, I subtracted 2 minus 1, that is 1. I added 3. Now there is a division. So when I'm doing division, 1 divided by 3, what it's going to be in the zero format, right? It is going to give you 0 point something something. But in the question, they have written us whenever there is something 0 point something something, we have to truncate it towards 0. So our answer is, we are going to pop this 2 and divide it, and our answer is 0. This is the way we have to do it. uh, and yeah, the time complexity is O of n, and space is also O of n. Let me start coding. So I'm using the stack, and it's an integer stack equal to new stack. Then I'm iterating the string for string token till tokens. There are 4 valid expressions we know. If token dot equals plus, then what will happen? If token is minus, then what will happen? If token is multiplication, then what will happen? I'm just writing those valid expression. If token is division, then what will happen? Just making a proper for you guys to understand. So these are our four expressions which we need to solve it, right? And other than this, whatever will be coming, other than this, whatever valid expression it is coming, other than this four valid, it might be a character, it might be a string, it might be a space or anything. We just have to convert it into integer and add it into the stack. Stack dot add integer dot convert it into integer dot pass and token. Simple. And then we have to return the entire thing. So whenever, what I said is, whenever we have positive, what we are doing, we are popping it off and adding into the stack. So stack dot or add, we are popping the two numbers, stack dot pop plus stack dot pop. Correct? This is the first thing which we are doing for addition. For minus, we are popping it in a equal to stack dot pop. We are also popping it another stack dot pop. Then I'm adding stack dot add b minus a. Next, for multiplication, again you can use the stack dot add. Same thing. I'm just going to multiply it. So instead of plus, I'm saying multiply. In the division, again you can say int a equal to stack dot pop, int b equal to stack dot pop, and then just divide it, right? Add that in the division, stack dot add b divide by a. Okay, and whatever we are doing it, we are adding it into the stack and then we are popping it. And else if these are not the four expression, there will be some other expression which we are converting into integer, because it is a token, it is a string, right? We have to convert into the token, sorry, we have to convert into the integer and then return whatever is pending. Return after popping out whatever is pending, we have to return it. Time complexity is O of n, and space is also O of n. Thank you for watching.